Hi there, my name is Dmitry Stolyarov. I am CTO and co-founder of Flunt. Today I'm going to be talking about GitOps, about what GitOps is and what it is not, what it really gives you and what it does not. Full disclosure, for the last couple of years Flunt has been building an open source tool named Verve, the entire goal of which is synchronizing the state from the Git with the states of a Docker registry and a Kubernetes. It is a CI/CD tool that drastically simplifies building images and deploying applications to Kubernetes. And I've been leading the design of the tool, so this whole video is, of course, the result of my journey. And it will show you how I've been influenced. But that should not stop us from digging into the heart of the matter. So let's go. Let's do it. The first picture that arises in my head when I hear GitOps is as follows. There is a Git repository. In that repository we have YAML files describing state for the Kubernetes. Here we can find two deployments, stateful set, and a definition for ingress resource. They form together some simple application. And on the other side, there is a Kubernetes cluster. And what we have in this Kubernetes is all our objects. So we have an ingress that is responsible for routing our requests. We have both deployments, let's say front-end and back-end, and we have a stateful set with Redis. The only missing piece is a GitOps operator. It is responsible for syncing the state from the Git into the Kubernetes. To do this, it periodically, or by event that can be triggered via webhook, for example, reads the state from the Git, reads the state from the Kubernetes, compares them, and changes the state of Kubernetes if needed. So, as simple as that. The Git repository with usually precompiled manifests, the Kubernetes cluster, and the thing that keeps them in sync. By the way, while it can run outside, almost always the GitOps operator resides inside the Kubernetes cluster. But to keep things simple, we draw it outside. Just keep in mind this detail. Just by using this approach, we already have some safety features. If for any reason some user directly modifies anything in the Kubernetes, the GitOps operator detects the change and fixes it back to the state defined in the Git. This makes a small fence that forces users, instead of going directly to Kubernetes, to make their changes to the single source of truth in the Git. Instead of the small fence, we can build a solid wall by not giving the user any direct access to the Kubernetes. Or we can make a kind of transparent wall with read-only access. But that is not important. What is important is that Git is the only way in. There is one more part of the equation. The Docker registry. If a new image arrives in the Docker registry, the GitOps operator will at some moment detect the change and propagate it to the Kubernetes cluster, so the new image will be pulled. So, that's it. That's how I see GitOps, and I suppose it is quite realistic. When looking at this picture, it is obvious that the state of the Kubernetes is not actually fully defined in the Git. The state of the Kubernetes is determined by the Git and by the Docker registry. When we read about GitOps, we can find that it gives us a lot of essential things, like idempotency, convergence, determinism, automation, observability, security, and audit. But What do they all mean? Automation. Automation stands for not making any manual changes in Kubernetes or any manual actions to synchronize the state from the Git. The operator, GitOps operator, is responsible for keeping everything in sync, and it does it automatically. And I agree with that. That's an important thing, and it's true. Convergence. Convergence means that the system tends to come to the desired state, and even if it becomes occasionally out of sync, it gets back on its own. Why might it be out of sync? Only two reasons. Either something has changed in the Kubernetes by some manual action, unauthorized activity or whatever, or changes have been introduced to the Git but not yet delivered to the Kubernetes. And in both cases, GitOps operator is responsible for getting the system back in sync. Strong plus for that. Idempotency. Idempotency signifies that we can repeat the synchronization operation several times, and the result of the first synchronization will not affect the result of the second one, and the first and or second one will not affect the third one, so we can perform the sync as many times as we want. But if you have compiled manifests committed in the Git, that idempotency is provided mainly just by Kubernetes API. And if you feed Kubernetes API with the same data each time, you will get the same result each time. So that is not GitOps merit. Determinism. Determinism indicates that the state in Kubernetes is wholly and entirely determined by what is written in Git. But as I've already told you, that's not true, because it's determined also by the state of the Docker registry. And if someone changes the state of the Docker registry, changes an image in the registry, you can say bye-bye to the determinism, and because of that, everything falls apart. But we'll get to this a bit later. Observability. Observability means the ability to know at any moment whether our system is in sync or not, and for being able to get an alert if it is not. Interesting. On one side, yes, we have observability. We know whether our Kubernetes matches manifest in the Git. What we don't know whether our system is in a desired state or not, because we don't know the desired state, since desired state is a combination of the manifests in the Git repo and Docker images in the registry. And we don't have the second one in the Git. We don't have the desired state of the registry in the Git. So only half of the state is determined by the Git, and only half of the state can be observed. Audit. Audit conveys that we can see all the changes made to our Kubernetes in one place reliably and conveniently. And this place is Git. But that's not true, because we have to also rely on audit functionality of the Docker registry, and then collate audit data from two systems, which is far from being reliable or convenient. Once again, if we ignore what's going on in the registry and consider only manifests as the definition of the state, yes, it will work. But for me, that doesn't sound like a real audit. Security. Security means not giving direct access for the CI system to the Kubernetes cluster. But that, in my opinion, is totally untrue. Yes, from the first sight, having the GitOps operator that resides inside the cluster and pulls the changes, and not having direct access from outside seems to be more secure. But no, not at all. The CI system or the user still should be able to push images to the Docker registry and still should be able to update manifests in this Git repo. That means that the CI system or the user has all the possible access to the cluster. And changing access from direct to indirect does not improve security. It just gives you the wrong sense of the security that makes the whole environment even less secure. You have to keep your CI secure. There are no other ways. So I would rather give a strong minus for that. Thus, on paper, GitOps gives us exciting, beautiful, very needed and also practical things, especially idempotency and determinism. They form the base for the whole thing. However, in what I've seen in reality and what I just pointed out, there are some questions. But even if GitOps really does everything, seeing the whole picture, I eagerly want to thoroughly challenge what is written about GitOps. Before challenging what is written about GitOps, let's think, what can we compare GitOps against? What is the usual way to deliver to Kubernetes? The most obvious and the most used way is just a simple deploy from CI approach. Let's look at how it usually works and with all the details. There is a Git repository, and this time it's not just a repo with Kubernetes manifests. It's our application repo that contains its source code and also the Docker file. Manifests for the Kubernetes also lie in this repo, but this time represented as a Helm chart. And most likely there should be some tests. Some CI system is connected to this repo. It can be anything. Jenkins, GitLab CI, GitHub Actions, any. And this CI system has a job or task, action, stage, whatever it's called, named build. And what this job does is it builds the Docker image. And then there is a job named unit test that tests the image, then a job named publish to publish the image, or actually images, there can be several, then a job named deploy, or deploy to stage, and at a first glance, this job just executes Helm, feeding the chart from the Git to it. But the chart is not enough. Usually you need also to feed information about freshly built images, new Docker images tags. So Helm receives new tags, probably from publish job, and receives the Helm chart. And based on that, Helm renders manifests and sends them to the Kubernetes API. And Kubernetes, in turn, converges to the desired state and pulls new images. By the way, you can change Helm to any other tool. There will be no difference. You will have some kind of templates, and you will have Docker images tags. And tags will be used to render, to compile these templates. Then there might be a job named E2E test that runs some end-to-end tests on the deployed app. And then, finally, a job with the name deploy to production that does the same as deploy to stage, but this time to the production environment. That's how usually CI-based deployment to Kubernetes is addressed. And let's just quickly evaluate how it performs by GitOps criteria. First things first, is it deterministic? And the answer is, it depends, but usually not. What I've seen in a lot of implementation of this flow is that the problem lies in the building of Docker images. Even having the source code and the Docker file in the same repository, and also really trying to vendor to freeze all the external dependencies in the same repo, we end up not having the guarantee of the reproducibility of our builds. Therefore, if for any reason we build our image twice from the same Git commit, we not only might have small binary differences, because that's two different Docker images, but we might get two really different images with different content. And having Kubernetes, we don't have any challenge with determinism of manifest applying itself. The challenge is to have consistent manifests. And because consistency of rendered result, rendered by Helm or whatever you use, results heavily relies on the consistency of the building and publishing stages, the end result is not consistent. So the whole flow is not deterministic. The second problem in what I've seen resides in tagging strategy. Although it looks simple, it turns out it is far from being easy to find a way of consistent tagging. The most natural implementation should be to use Git commit IDs and to check whether an image exists in the Docker registry, and if it is not, if it is, to skip building, and if it is not, build and publish it. So if you repeat this process many times, second and following repetitions will just do nothing. But I hardly ever seen this done right. Either tag is reused, so on repetition image is replaced in Docker registry, which usually gives completely unpredictable results, or tagging strategy is based on some data from CI system. It might be job IDs or something similar, so no idempotency. By the way, if some of the steps rely on the data from CI system, the state of Kubernetes will be determined not only by Git and Docker registry, but also by the CI system. So it's even worse. And once again, there are no idempotency problems in the manifest applying process. The problem is in the consistency of data we pass to the Helm. We pass to the rendering process. Thus, despite the Helm chart residing in Git, despite the Helm on its own being idempotent, you can change the Helm to the kubectl or any other similar tool, as I've already told you. Despite Docker file and source code also residing in the same Git, the whole flow is not deterministic and not idempotent. There is no guarantee of restoring our cluster to the state of the specific commit in Git. As you already know, idempotence and determinism form the very base of the whole process, and when they fell, everything else fell apart. We lose in convergence and observability because we just cannot repeat the operation. For being able to converge to the desired state, we need to be able to get the desired state. But we don't have a consistent and repeatable way of getting it. The same is true for observability. To observe whether we are the desired state or we are not, we need to be able to get this target state. But we are not able to get it, and that's it. We also instantly lose in the audit department, because the Git does not fully define the state. Git history may say something, but it is far from being the final or the only source of truth. I don't think we need to talk about security, as has already been said. Swapping direct and indirect access does not make any difference. So I would rather exclude security from the comparison. And I don't think we need to talk about automation because, of course, CI systems are all about automation. So yes, we deliver our changes automatically, but these changes are undetermined. There is one thing to mention about automation: feedback. To make proper automation, you should provide your user with a clear feedback. Just imagine, you make a wire transfer and the banking app says the transfer is successfully completed, and then it turns out it is not. because the message is wrong. Your request for the transfer has been successfully received, but the transfer was not made. And when we deploy apps in Kubernetes, we quite often get into this situation. When Helm or kubectl apply says successfully applied, it doesn't mean that our change is rolled out. It only means that the request for apps to be rolled out is successfully received. If that resonates with your experience, you might find either Verve or KubeDoc useful. The links will be in the description below. So, clear feedback is very important, and any ambiguity leads to a bad experience both for developers and engineers in charge for the CI and Kubernetes. Of course, done right, this flow might work. If you pay enough attention to the build stage and tagging stage, you should be able to make them idempotent and deterministic. And most of the time you will instantly get everything else, more or less, especially if you don't forget about clear feedback. So that's it. That's what we should compare GitOps against. But I want to make another step. Be honest with yourself. How often do we need to redeploy our application or deploy it in some historical state? When bad times come, some cluster disaster or some unknown change to the cluster, we will be in deep grief. But if we only deploy new changes, and if we do it sequentially, we can live with the non-deterministic and non-idempotent flow. I'm not trying to convince you that it's right. Quite the opposite. I'm strongly for the determinism and for idempotence. What I'm trying to say is that in real-world situation, you might be okay with non-deterministic and non-idempotent flow, and you might not want to invest a lot of extra effort to achieve this full safety. So the question is, how much are you ready to pay for this safety? Okay, on the one hand, we have GitOps. On the other hand, we have the standard approach, let's call it CIOps. On paper, one is almost perfect and the other is just bad. But as we discussed, the perfectness of GitOps on its own is quite questionable. And CIOps, if done right, might work, or might be even really good. But that's not the full picture. Whilst CIOps describes all the flow, from changes introduced in Git to them deployed to the production Kubernetes cluster, GitOps covers only some part of this process. Let's look at that bigger picture. There is a GitOps part. Actually, there are multiple branches in this Git repo, and there are probably several clusters, one for staging and one for production. But that's not important. What is important is that the main Git repository containing all the source code of our application and all the accompanying stuff was missing from the picture. It's the same repo that we've seen in the CIOps flow. Let's call them application repo and cluster repo. And then there is almost the same flow as in CIOps. The same build job, the same unit test job, the same publish job. They didn't go anywhere. The difference comes in the deploy job. We start with the same steps by taking information from the publish job about images and feeding it to the Helm. But then, instead of making changes straight to the Kubernetes, we, one way or another, make a commit into the cluster Git repository. Meanwhile, the GitOps operator is running, and it either notices new images in the Docker registry or new manifests in the cluster repo, and it does the job. It converges Kubernetes to the desired state. And you can run end-to-end tests as well. Few things to notice. First, we don't have feedback in our CI system. The deploy job says all green because it successfully committed new manifests to the cluster repo, but that doesn't mean the changes were successfully rolled out to the cluster. Therefore, we have to look into some other system. Most of the time, it's some kind of web interface of the GitOps operator. We have to do it even to know simple things like to check whether our new manifests are valid. Second thing to notice, the system is asynchronous. For example, the GitOps operator might notice the new image in the Docker registry before new manifests were committed and seen. So GitOps operator might apply old manifests with new images, and they may not match. The classic example would be the introduction of a new required environment variable in the new image that is not yet set in old manifests. Yes, eventually it converges, but you have to keep in mind the asynchronous nature of the deploy. Just what we needed. And then, finally, deployment to production happens. The right way would be to do it in the cluster repo, merge the staging branch into the production branch. You might also need to promote images from staging to production in the Docker registry, but that can be avoided by using the right tagging strategies. That's it. That's the whole picture. Real-life GitOps is not as neat as it is usually shown. And even if GitOps part does everything what is written about it, and I've told you that it doesn't, but even if it does, the overall flow inherits all the problems from CIOps and adds an extra layer of complexity. Yes, GitOps was built to solve the CIOps problems. But because of what's going on with images, with tags and Docker registry, unfortunately, GitOps does nothing. I think that GitOps, implemented in the described or similar way, is actually an anti-pattern. The whole DevOps culture is about the smoothness of the flow of changes from Git to production, from idea to production, and about collaborative work. But the above-mentioned implementation of GitOps deceives us by promising transparency and convenience, but in reality it obstructs the flow with the unnecessary intermediate repo, with the unnecessary wall, the wall between development and operation. But that's my opinion. What's irrefutable is that you cannot compare GitOps and CIOps. The right comparison would be to compare the whole process built around GitOps with CIOps. GitOps plus pipelines versus CIOps. Yes, CIOps might be non-idempotent and non-deterministic, and by being that it might harm. Yes, by using GitOps we get idempotency and determinism, but mediocre determinism, because half of the truth lies not in the Git repo, it lies in the Docker registry. And we don't receive feedback from the right place, from the CI system, where developers do all the things. And we get a significantly increased complexity due to new elements and introduced asynchrony. I hope now, having all the facts, you will be able to choose workflow that really suits your case. And if this video helped you in any way, please don't forget to like it. As I've disclosed at the beginning of the video, for the last couple of years we have been working on the open source CLI tool named Verve. And what we achieved is we solved the main challenge of this story as I see it. We've made the main Git repo of the application, to be able to really serve as a single source of truth. To do that, Verve is implemented in such a way that it guarantees idempotency and determinism of a build, tag, and deploy stages. And everything else is built upon that. Interested? Check it. link in the description below. But forgetting about Verve and our effort, what do you think about GitOps? I bet that the standard implementation of GitOps will be superseded by something that will give you both idempotency and determinism, but in a more practical, in a more convenient way, in a way compatible with existing CI approaches, in a way that doesn't build the wall. Should it be called GitOps 2.0? And that's where I'm gonna leave it. I hope you learned something new today, or at least you find this video entertaining. Don't forget to comment, like, share and subscribe. You make a huge difference by doing that. Thank you.